So I think like this session is about the web, right? But there's also a lot of things you can do interactive with the web. So for example, do you know Super Saiyan, the Dragon Ball? This is giving you Dragon Ball power. So if I stay still, the ball stays still. But if I move, yeah, then the ball is gonna move. And you can adjust the parameter of the program, so I can make the ball bigger, I can make it morph into different shape, I can change the color of the ball, and by just using the hand motion. So there's like a lot of things that the web can do, and I'm gonna show you how I did it. All right, so, okay, so off to the slides. Off we go. So again, Patches, this is a tool I made. It's like a tool to explore computation through audio and visual. So basically, if you compute, usually you get an array, you get a data structure, right? But what if you turn that into sound, into visual? Another thing, the idea of Patches is to connect things. On the web, you can do a lot of things. For example, you can run virtual machine. Here's like a virtual machine called UXN. I can connect it to an image processor. And then I can turn the visual of the game into something different. Maybe I want to make it scroll, and that's gonna happen. And maybe I want to add a little of a different color to it, make it red, for example, or change the color over time. So just using the power of the web, you can like basically change the image. Or maybe we want to modulate the scale, but I put the wrong syntax there, so there. So just using any input, you can morph it into whatever you want. Another thing is, a lot of us programmers, we're like good programmers, right? But sometimes we have other interests, like maybe you're interested in assembly, maybe you're interested in audio processing. So what I did is to make a tool where you can connect different things you're interested. So here I'm learning assembly, so I make a little assembly block, right? But also you can use the data from the assembly to make some oscillator. So this is a graph that plots the oscillation. So here I can connect the data that's coming off this virtual machine and connect it to a signal producer. So that's gonna produce a line, right? But what you can do with signal is you can do an XY plot. So if you connect two oscillators and plot an XY, you can create something like this. And all of this is done on the web. It's all done locally. Here's the first demo I did like when I was like trying to program this. So I was really into creating visual. So I was trying to see like, can I make a tool where I can just like program all sorts of visual and connect them together. So these are using GLSL, which is the web's native shader language, and using Hydra. But soon I actually ran into a small problem. 18 FPS. And I was really sad because like I built this nice little tool you can connect things, but the FPS is like so shitty. So the question is, how can we get from 18 FPS to 120 frames per second? There's a problem in this like screenshot. I want you to guess like, what do you think is the problem of this code? What is making it 18 frames per second? Who thinks it's 1? Messaging. Who thinks it's 2? From canvas. Who thinks it's 3? From the source. And 4? Output. So everyone is smart because you're all correct. It's because you're copying something from canvas. And I think many of you know, like doing things from CPU to GPU is like, oh hell no, it's really costly. It's really slow. So the question when you're doing GPU things is like, how do you get things to stay on the GPU? And this is like the calculation. If I run everything, right, it's gonna need to copy data from one node to another. That takes 8 milliseconds. But if I compute like how fast my code needs to run at 120 frames per second, 8 milliseconds, right? So only one node and it's already too laggy. So that's not cool. So one thing that we like to do on the web is web workers. So like traditional programming, you would push anything off the main thread. Because the main thread is already doing so much, it's rendering things, it's compositing stuff, it's doing all sorts of things. But what if you can send the data from the main thread to off thread and just let it compute? And turns out the web has a lot of these tools. There's web worker, there's off-screen canvas, which lets you render stuff off the screen, right? As the name says. There's an audio worklet, which lets you do audio stuff off the main thread. So that's gonna be the theme that makes it 120 frames per second. Now I'm gonna get really technical here, so you can talk to me after the talk, but the idea of the whole thing is that first you have a single canvas. So it would be a single thing that you can draw to the screen, but this has a shared WebGL context. And instead of painting to the canvas and copying it like a fool, what you can do is you can render to a frame buffer. A frame buffer is like a target that you draw something into, but it doesn't appear on the screen. It's like a temporary canvas that you can draw on. And as you write to that frame buffer, this is very fast because it's all on the GPU. And once you have everything ready, you get that one final image, put it onto the main thread. And this means that you can have like really fast rendering, so like 60 FPS still running on the main outputs. And the little previews that you see on the earlier screen, that's doing a GPU to CPU copy. So a little slow, but it's small, so it's probably fine, right? So here's how the code looks like. You create a single GL context that handles all the rendering. And in each of the nodes, you have a render target, which is like what you render to, and those are coupled to the texture, which is what you use for the rendering. And the really nice thing about WebGL is it gives us something called BLIT. BLIT is bit block image transfer, which means you can like basically when you render something, you can do a really fast GPU copy from that thing like instantly. So you can already do that on WebGL, but WebGL 2 just makes it a single instruction. That means it's like super, super fast. So you would just like draw to a render target, you would just render it out. So here's how that looks like. So you get like 60 frames and every preview is still running. So you still see shapes moving, but you get a really crisp final image. But that's a problem. Really, I ran into a memory leak. Have you heard of 250 gigabytes memory leak? And I didn't notice it for 8 months, so I'm stupid. Yeah, so what happened is there's one line that I forgot to like clean the frame buffer, and because everything's running at 120 frames per second, you can get 250 by gig memory leak. It took me 10 crashes before I can fix this bug, so please don't forget. And one thing that would be helpful is always profile your rendering. So I made a little profiler off thread that lets you see, hey, what's the P50? What's the P99? So it's similar if you're doing like server profiling, but just for your renderer. Okay, let's get more nerdy. The problem is you still have to copy from CPU to GPU, right? And those copy are actually really, really slow. And you have so many nodes that you have to do the copy. Can you speed it up? Here's the main problem. When you read the data from like a node, right? It uses an API called read pixels. So what that does is the GPU is gonna send your CPU like a pixel, and it's actually quite slow. The reason is that there's something called stall. Stall means that your GPU and your CPU does a bunch of stuff, and it has to wait. For example, it's sending data, the GPU is doing some stuff, wait. The CPU is reading some stuff, wait. And there's a lot of waiting, there's a lot of empty block of time. So the goal of doing GPU stuff is, how do you minimize the wait? How do you do as much stuff as possible? So this is like what I tried, and it works quite well, which is called a PBO. P means pixel. PBO is pixel buffer object. The idea seems quite complex, but it's really to minimize the stall. So the idea is instead of waiting for the CPU, hey, where's my pixel? Where's my pixel? And you're waiting for a long time, right? You simply write a request, like you write a mail, hey, GPU, do the rendering for me and put it in this memory. So it's gonna do that. It's not gonna wait for you. This is completely asynchronous. So that means like by the time of the next frame, it already did its job. And it's gonna fill this space as much as possible. So that means there's the wait is much more minimal. And so you can have like cool visuals like this. This is called phyllotaxis, which is like what you see in lotus flowers. So if you look at a lotus, like it's kind of something like this. So you can create really nice visual on the web. Another thing I've been experimenting, this is not related to like the topic of renderer, but I've been experimenting with letting people make tools to understand what they're learning about. So for example, if they're learning how to dance, right, they can, instead of like watching video, they can generate a set of dance moves. So like by running this on the web, this means like you don't have to install anything. Everything's on the GPU. I'm really bad at explaining, so AI is actually gonna be a little better than this than me. So you can go to DeepWiki, which is a tool that actually reads all the code, like yeah, and it's gonna make some nice diagrams. For example, you can see how FBOs work, how PBOs work. So yeah, so now let's see some more fun stuff. Audio, how do you handle audio? The trick with web audio is that you can write something called worklet. And this worklet can do work off-thread. That means you can run really intense computation and let it still work off-thread. This is called a Lissajous plot. So this is like an XY plot. So you can plot two data of the audio, one as X, one as Y, and you can get like, yeah, that's a really nice plot. Or you can also make a scope on the web. So you can see how the shape of the audio looks like. Or you can make a little curve editor where you change the curve and you plot that into an audio signal, and it's gonna try to follow the curve. So there's a lot of fun stuff you can do on the web. And what I recommend is try to abstract away the DSP. Because the DSP code, usually it can be very simple, but the web API makes it quite complex. So you can define your own simple function to create a DSP node. Another thing you have to do is, if you have your own object graph, right, you have to translate that to the web audio graph. And well, you can check out the DeepWiki or just talk to me after the talk. I'm always lonely. Okay, so last slide of the talk here is that I think the web is really cool, really powerful, and there's a lot of things like, for example, I think Pitang will talk about web LLM in the next talk. So there's just so much you can do on the web, right? And I think this is the gist that I wanted you to remember. You can do so much cool stuff on the web. Don't just let it be static text. That's it. Thank you.
Thanks a lot. We have ample time for questions, 8 minutes. So.
Oh, okay.
Yeah, you have 8 more minutes.
Oh, really? Then okay, let's do a bonus.
I didn't show you the 5-minute times.
Oh, really? Oh, sorry. I thought it's already over time. Okay, so time for bonus. Yeah, so you can ask me questions or I can show you cool stuff. Up to you. So, for example, okay, then I'm gonna do some extra content here. So, for example, there's a lot of tools you can use on the web to make rendering possible. So for example, let me show you something called Hydra real quick. So I'm gonna show you some shader stuff first. Okay, so this is a shader that Ty wrote. So the guy in the green shirt in the middle, I stole it. So this is so I wrote like a little tool where you can basically process the shader. So you can learn about like how shaders on the web work, but you can also like remix that. So I'm gonna remix this a little bit. So you can use a tool called Hydra. This is called Hydra Video Synth. It's a TypeScript library. So for example, I can do an effect called scroll. And let's do scroll by time. Scroll x time. So there's a lot of functions you can use to like manipulate video, manipulate audio, and yeah, it's quite fun and interesting. So you can also do modulation to modulate one source with the another. So I'm gonna do modulate scale, for example. So this is gonna use the inputs of another node as the modulator. So I'm gonna use this one and I'm gonna pipe this here. So something like this. Oops. Let's connect it here. Oh yeah, I haven't put in what to modulate, right? So that's gonna be source one. Yep, and you can have an effect like this. So this is quite interesting if you want to learn like how to get into video processing without learning like about shaders first. So just to get an idea of what's possible. Okay, any more questions, or I can keep showing you demos. Yeah.
So, any questions?
Yeah,
or wish list item, what to show?
Yep. Or I can actually show you like this in a production work sort of thing. So for example, I think I had the demo or open originally. Okay, no worries. But essentially, the idea is that you can create your own tools. So like build your own little tools and use them. Okay, so here's like one more fun demo. So this is like a graph curve editor. So I think it's the one that I showed you earlier, but you can basically like modify the graph and it's gonna try to follow the curve. But yeah, with live demos, sometimes it doesn't work. Yeah, actually, I think let's end it here, and I'm gonna give you the link to the repo if anyone's interested. It's heypoom/patches, and it's completely open source. And yeah, let's give back the time to everyone.
Last chance to ask questions. Yeah.
Yep.
How do we save our work on this?
Oh, okay.
And
so
also, like, is there any version management?
yes, so this is done. So this is essentially done on IndexedDB. So if you haven't used it, so you have local storage on the web, right, which is a key value store. But you can also store arbitrary data, for example, buffers and things. So we store it all on the IndexedDB.